Okay. Good day to all of you. Um, Welcome back to calculus. Then we have done the calculus topic 2 weeks ago, and anyway, I would like to indicate some of the problem that student requested me to solve for them, and the questions are mainly related to the quiz questions, and I hope that I can highlight to you some of the issues that's supposed to be highlighted to you. And this is the question that I've given to you in the during quiz. There were some mistakes. I agree with that. Okay, agree with many of you. Okay, there were some mistakes in the quiz, and because I selected the questions from some university site, but I made a mistake that I didn't check the complete work of that. But anyway, we take it that as a good learning, and do not worry also. I will not penalize your marks for these mistakes, because I already identified the mistakes carefully, and I already readjusted all the marks accordingly. Therefore, you do not worry, okay, about your marks. But the most important thing here is a learning, okay. And I would like to thank also some of you, those already highlighted the issues to me during the quiz time, and some of you also did the thorough work on this, and you indicated to me some of the mistakes. But anyway, I noticed there were some of you are requested me also to explain the topic into detail. I think this is right way to do, because I need to explain the detail, and I should clarify to you some of the aspect of this conservative potential what you call the vector calculus related problem. Okay, one of the problem that I would like to address here is this. Okay, find, okay, the potential. Okay, find the potential V E dot dr with negative 771 2412, and E has been given here 6yx2 I and 6xj and 5k. Okay, this question I extracted from some university site, but the problem is I didn't notice there were some mistakes in their solution. Okay, in their solution, but doesn't matter, because I managed to identify the problem exactly. But no problem, we learned, we take it this as a learning. Okay, we can see, but this is a very interesting question. Okay, interesting question to discuss. Therefore, I wanted to explain thoroughly, not to say, but I'll give you the idea. Okay, I'll give you the method and how to solve this problem anyway. Okay, now you can see this question involve find the potential V. Okay, is a work. Okay, in this particular case, we assume all the cases that we are dealing is a work, but it can be voltage or whatever, potential volt or anything. But as long as you can understand the logic that we are going through, in this case is a path integral. Okay, but you can see here with the 2 points here, 3D problem XYZ, and the important things, they did not mention anything in detail, the relation between the A and B. Is it a straight line, or they didn't give any equation relation between the A and B, but they have given a points. They have given a point, 2 point. Okay, they have given a 2 point here, 4 1 2. How to imagine? Can I imagine this is a straight line? Cannot, because we don't know. But there is a one way to identify the problem, this problem, this is related to the potential. When I say potential, this should be, can I assume this can be a path independent problem? Okay, can I assume this is a path? No. Let us try and verify whether this is a path independent problem. Okay, if when the relationship between the A and B can be a path independent, when? Okay, if there is a work 1, work 2, work 3, work 4, if we can identify the relation between work 1 equals to work 2 equals to work 3 equals to work 4, then immediately we can say there is path independent exists. And one more important message that we can identify from this, can we check whether it's a conservative or not? Okay, in order to identify this, and since this is involved 3D, okay, 3D problem, which is involved XYZ, and we can't use here in this particular case exact method. Therefore, only one choice we have, that is to verify whether this is the curl of the ghost is a 0 or not. Okay, in order to make sure if it is the curl of this is 0, then we can confirm this is a irrotational. Okay, we can identify this as a irrotational problem. Okay, if it is a irrotational problem, let us check whether then immediately we can say this is a path independent between A and B is exists. Okay, if first of all let us verify whether it's a path independent problem or not. Okay, if not, then we can't solve the problem. Okay, that is the funniest things. Okay, let us see. Okay, if it is a case, in this case, okay, how to identify that as I, J, K. Okay, this is a del X and del Y and del Z. Okay, and this I can write as a 6y, x2, 6x, 5. Okay, now very fast we can identify. Okay, in this case, if it is I, then you get 0. Okay, 0 I. Okay, you can get a 0 J. Very fast you can identify this is a negative anyway. Okay, negative. Okay, you check and see ZX to the 5, and this relationship between these two is a 0. Okay, now the last one very clearly indicate to us. Okay, if we hide this, okay, X, yes, this saying there is a 2, 6, X2 and minus the relationship between these two, we get a minus 6x2 where we get a 0. Okay, this solution indicate to us this is a rotational problem, and yes, this is actually a potential. Okay, it's a potential. And when we say potential, we need to make sure another information also. Do we can identify one is a potential, then they must exist. Okay, there must exist what we call a potential. Okay, potential function. Okay, they must exist a potential function. To say that as something like this. Okay, and now in order to solve this problem, let's say there is a f, this f is a potential function. You must remember f is a potential. It's not del f is a potential function, f is a potential function. Okay, there is a potential function. Okay, exists, potential function exists. Okay, if this is a scenario, then we can equate this E, the goes to the del f. Okay, now if we equate this del f to this 6y x2 I 6xj 5k equals to del f del x I del f del yj del f del z, del z to the k. Okay, this is the first time you are going to solve 3D problem, okay, 3D problem, and which is basically we can assume, we can check the relation between these two, whereby we take these two, okay, we take this similarity, okay, based on the sameness of this data, based on the I, then we can say del f, okay, del f to the del x equals to negative y x2. And if I solve this for the f, this is a very important here, really very important point to take note. When I solve this, I will get, okay, I will get a 6yx. And what is the constant here? What is the constant here? Very important. The constant here is a g. Can you guess? There are two, x, y, z. Okay. Some of the problem can be even we can go. Some student may say, can I go further? Yes, you can go further. You can say, for example, a, y, b, z. Okay, no problem, but as long as this is the function, the combination of the function. Okay, this is very clearly indicate there are two constants exist here. Okay, then how to solve? Okay, let me finish this part first. Okay, then we can see there is another one, that combination you can see is a del f to the del y, where we get a 6 over x. Okay, now can I move this one to make it del f del y? Can. Okay, let us try. Okay, wait, is it correct? Yes. 2 negative, yes. Okay, if I start moving inside, then I make it a del f to the del y. Okay, then I get here something very interesting, okay, which is basically it will give me a 6x plus g prime y base, which is a y z. Okay, now can we combine, can we compare these two? Yes, we can compare. Okay, we can compare, and we found this one is a 0. Can you see this? This is 0. Okay, if g prime to the dy is a 0, then immediately I can say, okay, I solve this side here, okay, y z is a 0, then by obvious y is a in this case is a does not involve. Okay, basically this one, or we can call it that as a hz. Okay, some of you may question, so it does not involve y at all. That's what I wanted to tell you. Okay, this when I make it a gy prime to the g prime to the refer to the y, and if it is a 0, then immediately it will downgrade it to the another status called hz. Okay, if some of you didn't get it exactly what I'm trying to say, okay, if it is because is you can see because it could be a hz, it could not, it could be anything like a c, but it should not involve y at all. Okay, when I make it a 0, then immediately it's understood that this function does not involve y. Therefore, it's become a 0. Therefore, immediately I can write this. Okay, if this is the case, del f to the del z, here I get a 5. Okay, and obviously, if this one f is a you can see here f is a 6yz x plus hz. Okay, now you see, if I start doing del f to the del z, okay, then I get a something very interesting results here. Okay, I should get a 5. That means this, okay, just let me do one solution here. I get a 5 z plus maybe I call it this as a xy. Okay, xy, you look at this one. Okay, z, okay, completely involved, but x y here, the combination is here. Okay, is here. Okay, can you get me? Some of you. Okay, if otherwise you can do the similar work. Okay, okay, I'll take it this way. Okay, you can start working on this. Okay, I'll take another paper. Huh? Okay, have a look on this first. Have a look on this. You can do this, or you pick this h. Okay, you can say if it is a g, then you can it will be downgraded to this. Okay, now go back here. Okay, if f equals to 6yx and hz, and is given here, okay, and is given here del f del z is equals to 5. Okay, now let us do this. Okay, we do del f del z. Okay, then of course this becomes 0. hz is something prime, right? And this both are same. Then if the both are same, then what is the hx? Okay, hz is a 5z plus c, right? Okay, can I take this and place inside here? Okay, therefore the f become 6yx. Normally I used to say don't add c, because f itself is a c. Okay, as you all know, when we solve f is a c. But anyway, I want you all to learn the skills. Okay, plus c. Okay, if this is a scenario, then f is a c, then okay, but anyway, because we want now, the purpose is to identify the potential function. Okay, this is a potential function. Okay, this is a potential function. This is a potential function. Okay, if it is a potential function, okay, how to solve the problem? Okay, how to solve the problem? As we learned before, I've told you that any work, okay, we are learning back the one of the case, because I taught you 8 cases, different cases to solve the functions, path integral. One of the things is, if we know b to the a, f to the dr, if we know there is a potential function f exists in this case, then we can quickly solve the problem as thus. Okay? Okay, but with the condition here, remember, for this particular case, f must be equals to del f. And this is what we learned. This is a theorem that one of the method that we learned, and this must be conservative, and it should be path independent. Immediately it's known as a path independent, path independent, where f is potential function. Okay, f is a potential function. Okay, we get back to the problem again. In our case, is a given here negative E dot dr, and where this is a 1, 2 and negative 7, 7, 1. Okay. If this is a scenario, then we need to solve the similar case with us. The same method that we need to use in this case. The path is a reverse order, but don't worry about that. Okay. The answer whether exists or not is not an issue, but I want you all to learn the skill. Okay, I want all of you to learn the skill. Here, F. Okay, we just picked a 4, 1, 2 minus F negative 7, 7, 1. Okay, done. Okay, we have done the problem. Okay, we have solved, and since C is not a constant, then it will automatically disappear, and this, okay, 6y, then we can solve, and I hope that you can get the solution. If the solution is not in the quiz, no problem, you can put it there as a no answer. Okay, but I want you all to learn the skill. Okay, many of you did ask this question, how to solve this question. Therefore, really I wanted to sort out one 3D problem, and this is quite advanced anyway, but learn the skill to solve for the 3D as well. Okay, anyway, thank you very much for those asked this question. Okay, because without you I won't know, okay, exactly this you all facing a complex problem in this scenario. Okay, I agree with that, because the book also didn't solve the problem properly. Okay, because the answer, I checked the answer of that book, and the book is actually did not clearly stated this problem. Okay, but come back to the another problem, one more problem that I noticed that suppose I should explain to you as well. And okay, another case, I noticed the problem. One of the biggest problem, I really I quite upset also when I see this question in detail, when I start working on this question and I try to solve, because there is a biggest mistake that in the problem in that question. Okay, therefore I deeply, I should apologize for that. Okay, I should apologize for that, because I didn't notice that problem in the these things, because I trust some university side, because sometimes they also making a biggest blunder in the problem. Let me show you the problem anyway. Okay, evaluate. The question is evaluate the Gauss law for D5. I slightly would like to change the question, because okay, please remember, some books I worried also, sometime even in the test or in the exam, you don't this time you are not going to go through the exam, but you may find during the next coming test, but I will try to monitor this anyway. I will check the question carefully. Okay, I'm not going to contribute in the exam questions, but I will check. Okay, I will check the questions. Okay, I will check questions carefully, because is there any consistency with my teaching? Okay, if it is not, then I will ask them to change, or I might change with my questions anyway. Okay, but anyway, you need to be very, very careful. Okay, what kind of problem basically that you can face here? Okay, the question here, evaluate Gauss law for, the original question is they put it as a R. Okay, because we learned our problem here, we learned for this for the spherical, for the spherical. Okay, we learned the F as rho theta phi, right? This is what we learned. Okay, some books, okay, these two are very different meaning, you know. Okay, some books, they will change these two to the different position. They will call the phi here, the theta into this. Okay, I will explain to you detail. Okay, now let me change. This is supposed to be R. They put it over there is R, but okay, no problem. You can change the question. Not to say question, the symbolic representation of the question in this. This is what I wanted to comment about. Okay, I want to comment about the I. This is the biggest blunder in the question. Okay, let me see. Spherical coordinates. Okay, I'll take coordinates. Take it as a learning. Okay, coordinates with rho for m and okay, because many calculus book they change it the theta to the phi. Okay, therefore many of them very difficult to identify whether they refer to the theta or phi. Okay, in this case I will clearly indicate to you this is the phi as volume. The question is something like that. Okay, the question is something like that. Okay, what is the difference between this theta and phi? Okay, try to get a good grasp on this. Okay, theta is not a phi is not a theta. Okay, there are, when we use a arm, we got a 3 arm. Okay, remember we got a 3 arms to discuss about. Okay, we take it this as an x. Okay, this is an y, this is a z. Okay, this is what our earlier definition of our spherical. Okay, some books, okay, ours we discuss the arm that we use. This is our arm. Okay, our arm that we use here in this case is a rho. Okay, some books is a R, they have written as R. And remember that we use the horizontal, okay, the vertical. Okay, this is referred to the vertical. Vertical. Okay, this is the phi referred to the vertical. This is a horizontal. This is a very horizontal. Okay, horizontal. Vertical and horizontal. This is a difference. If you not clearly manage to identify whether which one referred to the horizontal, which one referred to the vertical, then you may have a problem to understand the whole solution of the spherical coordinates. Okay, normally very rare in our questions, we ask spherical related coordinate system. But anyway, I want you all to learn the skill. Okay, spherical coordinates, you need to carefully identify. In our system that I taught you, okay, I fix it the theta as a horizontal and phi as a vertical. Okay, but the question in the quiz, they refer other way around. Okay, they refer the theta as a vertical and the phi as a horizontal. They exchanged these things. It's based on, depend on the problem. Okay, but anyway, you need to carefully solve the issue. Okay, now as I mentioned to you, this one horizontal referred to this side. Okay, this is what we call it as a theta. Okay, horizontal. When we move in the horizontal position, okay, we call it theta. And vertical, from here we come down. Okay, when we come down here, it's a vertical. Okay, horizontal refer to x to the y plane. Okay, we are moving around in this case. Okay, why I'm teaching this problem? Actually, there is a good learning inside here. Okay, although we made a mistakes, okay, there is a mistake in the question, but I really okay, because I wanted to highlight to you some of the problem that suppose you can learn from. Okay, in this question. Okay, one of the things that I want you all to learn in this case, Okay, if you notice something like R or something different, what you call identification, okay, or symbolic representation, first thing you make sure you adjust back or edit back to make it the same as our model, easier, okay, to make it a little bit consistent, therefore it's you never confused, okay, you never confused. One more problem that I noticed in this problem, in this question, okay, is the biggest problem is here, okay, in this case. Okay, now they want you to use a Gauss law for the D, okay, for the D. Okay, now the question here, in order to solve this, the problem to solve in this case is this. Okay, we go back to the original. The Gauss law is we take a D. We cannot speculate here. We don't know yet what is supposed to be, but let me show you this. And dV. Okay, now what is the object that suppose we need to get for this? Okay, you see, if I say this is a horizontal is a pi, is a 90 degree, right? And what about the theta? Theta is not given. And they want you to find out the volume. Okay, the question is not well designed. The first problem is the question is not well designed. I agree. Okay, that's why I told you earlier. I apologize for that. But anyway, coordinate with this, and we can see the side is a 90 degree. Okay, it's 90 degree, but I think I did provide you some help in that. Okay, if it is this, it's a hemispherical. Okay, this question is actually referred to the hemispherical problem. Okay, it's a hemispherical problem, just because you take it as a learning. Okay, now there are three things that I want you to quickly design. Okay, therefore if it is a hemispherical, because you can see this is a 90 degree, and what about the theta? Theta is a 360, because they didn't give anything. Okay, they didn't give. They say these two are controlling point. Definitely the rest must be complete, right? Although they didn't mention. You may argue, sir, you didn't give the other one. Okay, you didn't give the other one, which is, but of course this is a constraint you are having, but the rest is not constraint, means you need to see the whole spherical, right? Okay, you should see the whole spherical, but this is a control for the 90 degree, and this is a 4M. That means you can see the control in these two cases, but the rest is a free. That means is free means it's supposed to be a one complete spherical, because it's already given spherical, right? And therefore the three things that we can imagine in this case is a phi basically is moving 0 to pi over 2, and theta is not given, but okay, theta is understood. If it is not given any constraint, we use fold. Okay, many of you never agree with me, but this is sometimes some cases is agreed, because it cannot be 0, right? You know, definitely it should be a fold. Okay, then the next one is rho is a 0 to 4. It's moving in this 3. Okay, this is a good learning anyway, because we know how to identify the range of this. And one more thing that I wanted to teach you is there are many things to learn here, many things to learn in this question. Okay, dV. Let me teach you dV, and after that I'll go back to in this one. This is a problem. This is the biggest problem that I wanted to highlight to you. Okay, in this case, let us how to identify the dV. Okay, dV for the spherical coordinate, I have taught you. Okay, I have taught you this is a range. This is a range. Okay, this is a range. Now let us identify the dV. Okay, dV for this particular case, let me draw. Okay, okay, we know there is a theta. I am teaching back again. Okay, we know this is a R. I told you this is a horizontal. When it come back to the horizontal, it's a become a rho to the sine phi. Okay, the arm automatically become on the horizontal. Okay, in the horizontal state, it's referred to the rho to the sine phi. Okay, it's a complete horizontal here. Okay, you can test if it is a 90 degree. If it is a 90 degree sine, it's actually you can it's a depend on the how do we identify the phi based on the phi. 90 degree is a phi completely, you can see phi, but for the every single cases, remember, because you see I wanted to teach you some idea why is this. You see the spherical is not a complete one. You see, according to according to the state, okay, you see, if it is this is phi, this is another phi. Okay, you can see another phi. It's a difference. Okay, because when you wanted to identify the circle inside the spherical, okay, we need to use this phi sine rho sine phi. Okay, then we already learned, I already taught you this part anyway, sine phi d theta. Okay, what about, since we pulled up bit, okay, this is surface. Okay, we wanted to identify the surface. If it is a surface, how to identify that? Okay, that one is a rho to d phi. Okay, now we wanted to go inside. Okay, we wanted to go inside this one. Okay, in this particular case, then immediately we know this will be d rho. Okay, now we combine all this together. Okay, we go inside. Okay, we can identify that as a rho to, okay, rho to sine phi d rho d theta d phi. Okay, done. Okay, this is already given to you before. Okay, this part also is known to you. I already taught you before in detail. Now, what is the next stage that I want you to understand here? This one. Sorry. D. Okay, I. Okay, look at this one. There is a problem that I wanted to highlight you. To highlight to you. Okay, one of the problem that I want you all to see here is this. Over here it's given as a I, but this one referred to the rho. And how to use this? Remember, there are problem when we see if it is a rectangular, okay, rectangular del referred to the del xi, del yj, del zk. When I say I bring this d here, okay, then yes, I will get del rho to power 2 over 4. But I cannot solve for the x. Okay, because it's not referring to the x. That is the biggest problem that we can see. Okay, when I translate this rho 2 to the x, I need to change it the rho into the x form. Okay, which is, but in this case they didn't set the question as something like that. Okay, the question is actually is not referring to the rectangular base del. That is the one of the problem that we these things because they made a biggest mistake here. Because the answer supposed to be they use there are two things which I'm not going to go through in detail here. This is we didn't learn in our syllabus. Okay, but anyway, I would like to stress this part. Okay, I should stress this part. Although you never learned, there are other del also. Okay, there is a cylindrical. Okay, cylindrical del. Okay, cylindrical del referred to as something called dr r as a unit because we need to change. This is referring to the xyj. Okay, this is referring to the coordinate system called x, y, z. Therefore, we cannot use this one in the calculation of spherical coordinate which related to the row where we are referring to phi, theta, this formula, spherical. Therefore, it need to be converted properly. It should be converted properly in order to work for the del D. Okay, but don't worry, I didn't teach you this part. I'll tell you where is the